Okay, so 4.3 is on parallel and perpendicular lines. So your learning target is that you will be able to identify and write equations of parallel lines, and you will be able to identify and write equations of perpendicular lines. So parallel lines are two lines that never touch or cross, and they have the same slope. So that's something that you want to remember about parallel lines. They have the same slope. Then down here, we have our perpendicular lines. And perpendicular lines intersect at a 90-degree angle. And that's what this little box right here means. And what you need to know is that their slopes are opposite reciprocals. So meaning they have opposite signs. One is positive, one is negative, and then the numbers are reciprocals of each other. Okay, so for example one, we're identifying parallel lines. And so we're given this graph that has 3 lines on it, and we need to find the slopes of each of these lines to compare them to determine if any of these lines are parallel or not. So since we're given the graph, if you want, you can count your slopes. So for this first one, if I'm starting at this 0, 3 point, I go up 1 and over 3. So my slope for line A is positive 1/3. And again, for line B, we can go ahead and start at the 0, 1 point. We go up 1 and over 3. So our slope for line B is also 1/3. And then again, we are going to count our slope for line C. So we're starting over here at -2, -2. So we're going to go up 2 and then over 1, 2, 3, 4, 5. So our slope for line C is 2/5. So now that we have our 3 slopes, we can compare them. And looking at our slope for A and our slope for B, you can see that these are the same slopes. So we can say that lines A and B are parallel. So this would be our answer here. Example 2 is writing the equation of a parallel line. So our directions tell us that we want our line to pass through the point 3, 1 and is parallel to the line y equals 3x plus 1. So looking at this line, our slope here is 3. So that means that our slope parallel, so I'm going to put an M with a little parallel symbol here, is going to be 3. Then we're going to use this point as our x1, y1. So that means that we're going to start by using our point slope formula. So we have y minus y1 equals m times x minus x1. So we have y minus 1 equals 3 times x minus 3. We're going to distribute this 3 in. So we have y minus 1, we brought that down, equals 3x minus 9. And then our last step is to get that y by itself. So we're going to add the 1 to both sides. So we have y equals 3x minus 8. So this is the equation of a line that goes through the point 3, 1 and it was parallel to this given line. Example 3 is identifying parallel and perpendicular lines. This time we're given 3 lines, but they're not on the graph. So we actually want to change all of these to slope-intercept form. So we are able to identify the slopes so we can compare them. So line A is actually already given to us in slope-intercept form. And so this is our slope right here. So for A, our slope is 2/3. So now we need to change our equation for line B into our slope-intercept form. So we have 3x plus 2y equals 8. So we want to get this y by itself. So we're going to start by subtracting the 3x from both sides. So my 3x's here cancel. And I have 2y equals negative 3x plus 8. So I'm putting the x term first because this is going to be consistent with our slope-intercept form. So then finally, to get the y by itself, I need to divide each term by 2. So when I do that, I get y equals negative 3 over 2x plus 4. So now that this is in slope-intercept form, we can identify our slope, which is negative 3 over 2. And then finally, we can work with our information for line C. So we have 3y minus 2x equals negative 9. So again, we want to solve for y. So I'm going to add my 2x over. So I have 3y, these cancel, equals 2x minus 9. And then again, I want to get the y by itself. So I'm going to divide each term by 3. So I have y equals 2 over 3x minus 3. So looking here, my slope is 2/3. So going back to compare all of the slopes, my slope for line A and my slope for line C are both 2/3. So we can say that lines A and C are parallel. And then if we look at our slope for line B, we have negative 3 over 2. So looking at positive 2/3 and negative 3 over 2, I have a positive, I have a negative. So this has an opposite sign. And then I have 2/3 and 3 over 2. So this is the reciprocal of this. So lines A and C are parallel, and they're actually both perpendicular to line B. So we're also going to include that in our answer. So lines A and C are parallel, and both are perpendicular to line B. And this is our answer for the example 3 problem. Example 4 is writing an equation of a line perpendicular. So we want the equation of a line that passes through this point and is perpendicular to the line y equals 4x minus 1. So here's my slope of this line. So that means my slope perpendicular. So I have my m, and then this upside down capital T is a symbol for perpendicular. So I need to figure out what my perpendicular slope is going to be. So if my original slope is 4, positive 4, that means my perpendicular slope needs to be negative. And then if this is 4 over 1, I need the reciprocal, which is going to be 1 over 4. So negative 1/4 is going to be my perpendicular slope. Then my point I'm using as my x1, y1. So we're using, again, the point slope formula. So y minus y1 is equal to m times x minus x1. So I have y minus negative 3, which is going to become y plus 3, is equal to negative 1/4 times x minus 4. So we're going to go ahead and distribute this negative 1/4. So I'm going to bring down my y plus 3, and I have negative 1/4 times x, which is negative 1/4 x, and then negative 1/4 times negative 4. So negative times a negative becomes positive, and 1/4 times 4 is 1. And then lastly, I'm going to subtract the 3 over. These cancel, so I have y equals negative 1/4 x minus 2. So now this equation is the equation of a line that goes through the point 4, -3, and is perpendicular to the given line.